Okay, welcome to my talk. This is the external secrets operator, a cloud native way to manage your secrets talk. Here we'll be talking about this project that we are very fond of. I'm Lucas, and I'm a cloud native engineer at Container Solutions. Here we help companies to adopt cloud native technologies to practice these cloud native practices and to improve their processes. Sometimes this even some means to move outside of cloud. It depends on the strategy and all that. I'm also a mentor at some mentorships, so I help some people do their first to make their first open source contribution. I also help some underrepresented groups to land a tech job. And yeah, I really enjoy helping people get into tech. I'm also a maintainer, of course, of external secrets operator. And my experience is basically with sysadmin stuff, backend development, system architecture, and cloud in general. So here is the agenda. First, we are going to go over the problem. So introduction about why we need this project, why we need external secrets operator. Then we are going to explain the solution and why and how what the hell operators are. Then we are going to tell this beautiful open source story about the community that got around this project. And after that, I'm going to show the state of it, how it works right now, and then we're going to do a demo. So the introduction, so our problem. So it's normal in your company, you probably have some environments, so development, staging, production, maybe you have some other ones. And in each environment, you have a lot of services running, and each service will need credentials to access stuff. So basically, your backend needs credentials to access its database. You need credentials maybe to access MailChimp or maybe SendGrid or whatever third-party solution you have on your company to do stuff. And you have tokens, you have certificates, you have usernames, you have passwords, and all these credentials, we call them, to make our life easier, we call them secrets. And it's easy to get hundreds, maybe organization of secrets to manage. And this is a problem because usually it's hard to handle rotation of that. So you need to have scripts, you have to maybe prepare your own automation to do that, depending on what you're doing. It's hard to onboard new services. It's hard to onboard new people with specific accesses. And it's hard to distribute secrets securely. And what we want, this is a possible solution to some of this project, some of these problems. It's not necessarily, this won't solve all of your problems. You need to still need to figure some things out. But what we want is to have a multi-featured solution, established solution like AWS Secret Manager. And we want to still use Kubernetes secrets inside the cluster. So that's the main goal of using external secrets operator. And of course, this thing in the middle, synchronizing this all the time, is the external secrets operator. So this is the solution that we want to bring. And what's the appeal of synchronizing secrets? So what's the appeal of keep these secrets on established solutions? So the first one is you already have some integrations to these services. So if you're using maybe AWS Secret Manager, you already have some other AWS services that use AWS Secret Manager. You can use secrets on AWS Secret Manager. So you can use them like this in the cloud on stuff that already have integration with it, and you can use them in your cluster. And you just manage your secrets on AWS Secret Manager, for example. You can use great features of these services. So like encryptions at rest, easier rotation mechanisms, maybe also random secret generation, and any of these features that you could have on these services. you can declare your secrets in source code, and you can avoid access to the actual secret. So you can use GitOps here and start using some stuff to have code that declares the creation of secrets instead of having secrets on your repositories. And these secrets will be created on the cloud, and the operator will synchronize this to the cluster. So with that, you avoid access to the actual secrets. You just have access to the code that generates it, and you can have the same manifest in a way, and just use the pattern and just change for environment specific secrets. So you have uh, basically the same manifest for development, for staging and production. You can just use them to get different secrets. And with that, you keep your secrets where it is secure, like in a service made for that. If you trust the service, so maybe you trust HashiCorp Vault and you have an installation of that and you're using that. Maybe you're using Google Cloud Secret Manager. Maybe you're using AWS Secret Manager, and you just keep using it. And okay, we have the problem. We know kind of how we want to solve this, but the thing is, in this project we use operators, and I want to take a step back and explain operators. I think I can go a bit fast because of this, since this is a Kubernetes conference. But let's go over this explanation. So Kubernetes works like this. We have Kubernetes controllers that are watching both your Kubernetes objects and the things that are actually happening in your cluster. So your Kubernetes objects would be pods, deployments, and services and whatnot. And you have controllers looking at them. The objects are the definition, what you define. You create an object and you define the state that you want. And then on the cluster, you have what's happening in the cluster. And what the controllers will do will basically look at what's defined. If we have a difference, we'll act and correct this change, this difference, to be what you defined. And okay, so what's an operator? What do they have in common with Kubernetes controllers? Basically, an operator is imitating what a Kubernetes controller does. An operator will look at some Kubernetes objects, but now we'll create custom objects. So with custom resource definitions, we'll say to Kubernetes, okay, please support these other objects. Of course, the Kubernetes controllers will ignore these objects. They don't care about them, but our operator will look at them, and they will be the definition of the state that we want. And then operator will look at the cluster or whatever you want it to look, and it will act based on that. So in our case, we'll look at external providers, secret providers, and the secrets that are on the cluster, and we'll make sure that they are sent, and some other stuff, of course. So observe, there's a diff, act. Observe, there's a diff, act. And okay, so we have the problem, we have the possible solution. We know that we want to create an operator, but how this community got together. So we wanted to centralize external secret solutions. And this is a beautiful open source story. It all started with this solution, the most popular kit in school. It was the most popular project, Kubernetes External Secret. It was created by GoDaddy. They had 2,000 stars, a lot of users, a mature code base, a nice community engagement. So if you go to the official Kubernetes Slack and you go to External Secrets channel, they were using that before, and now we are using this as well. And it is also expansible, and you're able to add new providers like Easy. So it was a nice solution. They supported these providers, and you can look at the repository to be sure. But okay, so they are a nice solution. They seem to be popular and they have traction. So why do we need a new solution? And I'm saying that we need a new solution. And it was basically because they were developing JavaScript. And I don't want to say bad things about JavaScript. JavaScript is not inherently bad. It's not a problem with the language or the ecosystem and nothing like that. It's just that when we compare with Go, at least for us and the things that we wanted, Go would deliver a bit more for us. So it has first-class Kubernetes SDK support. So and we have clients that are like really updated and are really used by Kubernetes people. So if you think if Kubernetes itself needs a new controller, they will use controller gem to generate code for that, and then they will develop a controller on top of that. And we can use the same thing that Kubernetes developers use to create a controller. We can use Kubuilder that uses controller gen underneath, so we can be closer to what happens in the real world. And then tooling, right? You can use Operator SDK or Kubuilder. And in our case, we wanted to use Golang templating. So we wanted to have a way to have dynamic changes based on our manifests. And this was made possible because we were using Golang and we were already thinking about Golang templating would be a nice pattern to follow. And the first step, in a way, was to notice that this was a problem that a lot of people were trying to solve. So in this issue on the GoDaddy repository, issue 47, this user Max Labor reported that, oh, this project is similar. Then, oh, this other project by Container Solutions is also similar. Oh, this other project is also similar. And we ended up finding a lot of projects that were similar. I'm giving credit to some of them here on this slide, sorry. But if you look at the issue and maybe some other PRs, you can see that there are maybe more than 20 or something like that solutions doing basically the same thing. And in these solutions, in these issues and these discussions, we started discussing what to do. And eventually we need to develop a new solution. But before that, let's create a new common CRD. So Moritz started this effort, this initiative, and he created a pull request, and we started discussing there. And the idea was to have a CRD that would deliver on all the use cases and would be nice and extensible, and we could easily adapt it and all that. And it was nice because some of the solutions at the time started working their way into this CRD already to future-proof the implementation and start testing like, okay, this is a CRD that we could make a new solution over it. And just a summary of what's happening here. So we had the issue. We found a lot of solutions that were similar, trying to do the same thing. Then Moritz started the CRD discussion, and we discussed on it, and we defined stuff. And then we created a project, a new organization, External Secrets, a new project, External Secrets. This is the new Shining solution. And we got together with GoDaddy. We also discussed with them, and they decided to also transfer their solution to this organization that we're controlling now. And we have both solutions there, but the idea is to make everyone migrate to the External Secret solution. Eventually, we can also use some GitHub magic to maybe use the stars that we have on the GoDaddy solution. And okay, so what's the current state right now, and what is happening with the new solution? So we have this new organization, the new project. The first, we got AWS Secret Manager parameter store implemented as providers, then HashiCorp Vault. We implemented templating functionalities, as I said, with Golang templating. We added more providers, GCP, Azure, IBM, Alibaba, GitLab variables, and we have a lot of providers right now. And we have some other features that are a bit more complicated, like creation policy merge. If you already have secrets, what happens, and all this stuff that we started to uncover. We had a lot of fixes and behaviors that we had to change over this past releases. But the goal right now is to make it stable. So most of, I think all of the providers are on alpha stability in a way. and we want to promote them to beta and to stable. And for that, we already have users using this project. We have some companies already trying to use it, but we also want to have like proper end-to-end tests. We have a lot of them, but we want to use them with real infrastructure, and we want some things there to make sure that everything is stable. So how it works, it's basically the same thing that we had on the original solution. So you deploy the operator as a deployment in your cluster. It will look at the CRDs, and based on the CRDs, it will know how to contact your, in this case, your cloud or Vault cluster. And also based on the CRD, it will know what data to get from your provider and how to create a Kubernetes secret that will have that data. So this is the split CRD that we decided at the end. We wanted to have two CRDs with to split responsibilities here. So one CRD is just to make sure that the operator knows how to contact your provider. So contact your cloud or whatever. So it has credentials, knows what project to talk to on Google Cloud, if it's AWS, what region, if it will use what authentication method it will use, if it's like a server's account key for Google Cloud here or whatever. And then the other CRD is the external secret CRD. So the first one is a SecretStore CRD. The second one is external secret. And then the external secret needs to reference a SecretStore. So SecretStore ref, the name is example, the kind SecretStore. So it's referencing the SecretStore on the left. And the refresh interval, so to let the operator know like what is the frequency that you want this secret to be refreshed. I would not recommend 15 seconds like it is in this example, because you can reach rate limits on your cloud or something like that, depending of how many secrets you have and all that. And then this target field, you'll have the name and creation policy. The name will be the name of the secret that will be created in the Kubernetes cluster. And then on the data, the secret key will be like this demo key would be the key on the secret to be created secret. So this will be the key where we're going to sync in the data. And then on the remote ref, we have this key, and it will, this is the name of the secret on the cloud, the name of the secret on the provider. So demo secret will be the secret on the Google Cloud, for example. So here, it's just because here you can notice that we are referencing a SecretStore with name example and kind SecretStore, and this maybe makes you think that we'll have another kind, and we have the ClusterSecretStore instead of the SecretStore. The difference is that the SecretStore is namespaced and the ClusterSecretStore is cluster scoped. So basically, if you want to have for example, a ClusterSecretStore, only one of them on your cluster, and maybe all of your external secrets on your namespaces can just reference this ClusterSecretStore, and yeah, of course you can do that. Of course, you need to be a bit more careful with RBAC and all that, but yeah. And here, just an example of something that is pretty useful. So basically creating Dockerconfigjson secrets to be able to pull images from private registries. So you create, this is an example on Google Cloud. So you create a Google Cloud Secret Manager secret named Dockerconfig in this case, and then you put a JSON string that is the configuration for this Dockerconfigjson. And then you can create an external secret like this using the template functionality. So here on target, the name will be the same, secret to be created, but then the template will tell the operator to create a final secret that is a Dockerconfigjson, and it will sync the data on a key that is named .dockerconfigjson, and it will get the data from this reference here, my secret. And it will, here we need to use Golang templating to move from byte array to string, but it doesn't matter. So this manifest will create a valid Dockerconfigjson. So let's go to a demo. Okay. So I have a cluster I created a cluster with kind locally here, and I have Google Cloud configured here, a secret already. I have this demo secret. I'll create a new version. I'll make a great value. The value of the secret now is great value. And okay, so first thing, let me just see if I have access to my cluster here. I need to install the operator, right? So you can go to Artifact Hub and you can look for external secrets and you find a project. First, you need to Helm add it, and then you need to install it. Here I'm name. Okay, so installed. This will install CRDs and the, of course, operator and all that. After that, I go to the application provider, Google Secrets Manager. And the first step is to create a secret that will store the JSON string that has the private key of your service account. You need to generate the JSON. To do that, you can go to your IAM service and then create a service account, make it have secret manager assessor role permissions, and then generate a key and then just put it here, and then create a secret on your cluster. So let's do that. I already have it prepared. So okay, apply samples secret .yaml. So I have a secret that has credentials to access my cloud. And then I need to create a secret store that has references to the secret. So if I go, let me add a folder here. And if I go to here, so I want to create a secret store. Name will be example. I want to use GCP provider, and then the authentication will reference that secret that I just created. So here, and we'll get the credentials from that secret, and the project ID is my project ID in this case. So this looks okay. Then the operator will know how to contact, in this case, Google Cloud. Okay, apply SecretStore TCP.yaml. Okay. What's the next step? We need to create an external secret. So in my case, I have an example here, and this is it. So the kind will be external secret, the name example, refresh interval 15 seconds. I want to reference the store that I just created. So example, secret store. And here it's example and the kind of secret store. So it seems fine. Then the target, the final secret that will be created by the operator will be named secret to be created. And it will get, let me delete this. It will get data from a secret named demo secret on the cloud. Here, demo secret. And it will sync the data on this key, demo key, on the secret that will be created on the cluster. So let's do that. External secrets GCP.yaml. And if I get secrets, it's secret to be created. And if I JSON path it, so secret to be created -o JSON path, and then I want to get from demo key. So this is the Let me show you. Okay, describe secrets, secret to be created. Here, it has a demo key. We get secret to be created. On the data, on the key demo key, I want to decode it with base64. It's great value. And if I change it here, maybe add a new version, another value. Eventually, yeah, another value. So it's there. And then you have some other options. You can comment this, and you can use the data from field instead of, and it will get all the key values of this secret. So we can do something like this. As very strong password, and then we can get, it will have the two keys that are on that JSON string. So user, wait a bit for it to sync. I have to apply, right? Okay. User. Okay. Focus, and then the pass is this one. You can also get a specific key on a JSON string. So you can do like property. User. No, I have to apply this. It's demo key. The secret key is demo key. Focus. So we got from this key on the cloud secret with this name, it got the data and stored on this new key on this new secret. And that's it from the demo. Besides that, you can reach us and you can contribute to this project. We have this repository on external secrets, external secrets. We have a website at externalsecrets.io. We have community meetings. You can look for external secrets on YouTube, and they are recorded and uploaded there. We are using the same Slack that GoDaddy used before for external secrets. So we are basically sharing this Slack channel, and you can ask questions about both projects there. The idea is to make everyone migrate from the GoDaddy solution to ours, so that's why. And then there's this blog. You can look for the birth of External Secrets community. You can also send this link somehow later. And I talk about everything that I talked here, but also I give an example of how to add a new provider and how to change the code and all that. Besides that, Container Solutions is hiring, and please reach out to us. We do real career plan, personal development, and public speaking, and working with clients that are really big and really interesting. And we also work with open source, as you see here. Reach me out on Twitter, reach out Container Solutions on Twitter as well. And that's it. Thanks a lot, and send me all your questions.